Fields of application: gas tanks in developments, plants and butane gas bottles, refineries and chemical plants, aviation, military vehicles, aircraft and vessels, helicopters,
every motor-powered movement,
terrorism and public transport, vehicles and tanks, gas pipelines, oil tankers and fuel transport trains, etc.
However, the potential for danger is high when storing and transporting explosive goods. Dealing with them responsibly has become one of the major challenges of our times.
Ampute anti-explosive materials are made of special aluminum alloy. A tank of 1 cubic meter only needs 28 to 32 kilograms mesh materials and only occupy 1.0% of tank. Ampute materials can stabilize fuel in tank and prevent fuel rocking, also eliminate static electricity and prevent the wall of tank from rusting, absorb heat and reduce the temperature in vessel greatly. Ampute materials are highly corrosion resistant. Once installation, permanent use. It is dangerous to produce an explosion in case of the need to repair damaged fuel tanks, containers or oil pipelines with welding. But if these vessels are filled of anti-explosive materials, the explosion won't happen even we repair the welding with fire. The next test shows the performance. Pour fuel into the tank and drill, ignite and repair the welding. You can see there is no explosion. You will see there is no explosion from the vessel with anti-explosive materials.
When pressure is increased due to overheating, the soldering is affected and the gas escapes. The enormous heat generated by 20 liters of petrol and 25 liters of diesel oil increases the pressure yet again, producing the expulsion of the mixture, but not a boiling liquid expanded vapor explosion. Since the contact surface of the fuel inside the bottle with the aluminium is increased by 3,000% thanks to the effect of the netting, the nucleating effect of the fuel is avoided, and thus a boiling liquid expanded vapor explosion. After 2 minutes, the bottle cracks. Part of the gas escapes that refrigerated the walls. The material is weakened. A crack is produced due to the enormous pressure, and the boiling liquid violently evaporates. Nucleation.
This example illustrates the problem. A standard 20-liter petrol can filled with fuel is warmed up for 90 seconds and then shot at to simulate damage to the outer cover as a result of pressure. The reaction is just as destructive as with the jumbo disaster in Taipei. A second can is equipped with EXPLOSAFE. After the shooting, the petrol burns out under control and there is no explosion.
Tank sections containing rapidly igniting fuel can become flying missiles, traveling great distances, causing secondary fires and other damage. It all happens quickly and with little warning. Where flames impinge on the tank below the liquid level, the liquid absorbs the heat, allowing the tank metal to remain at a safe temperature. With continued relief valve operation, the liquid level drops, exposing a greater area of the tank to the effects of heating.
Risk of explosions produced by fire completely disappears. Overheating of the deposit that increases fuel tank pressure. Bursting, and then producing the boiling liquid expanded vapor explosion. The risk of explosion produced by impacts or poor handling also disappears, since flames can be put out by simple manual techniques.
The safety of the passengers in the case of an accident has increased significantly. Today, not only celebrities and national leaders profit from this security, but also the shipping industry and the army. Even repetitive shooting with high-caliber incendiary ammunition did not result in tanks exploding during tests.